We'll next see how we can find the loop transformation matrix so that the outermost loop can be executed concurrently. Okay, first, since a unimodular matrix has full rank, meaning it all its rows and columns are linearly independent, and we want to find a matrix DU with a leading zero column, we cannot rely on U to get that zero column. I mean, it must be the case that D cannot have, I mean, should not have full rank. U certainly has full rank, and if D also has full rank, then we cannot get the leading zero column in the distance matrix of the transformed loop. So it must be, I mean, D cannot have full rank as well. Okay, so how can we find this transformation matrix? That is what I just mentioned. So what we do is to take the transpose of the distance matrix, and then we can use echelon reduction to find the unimodular matrix V and an echelon matrix S, like this. Okay, so it's the same at the top of this slide. And say we want to find one loop that can be run in parallel, meaning the DU should have one leftmost zero column, and then the second column should have integers at least 1. I mean, greater than or equal to 1. And the remaining columns don't matter. So what we will do is to find a matrix A, and from A we will find the transformation matrix. Okay, and the distance matrix times this A should have a certain number of leading zero columns. In the example here, we want to have one zero column. And then the question is, how can we find this A? Okay, if we take this row as the first column of A, then when we multiply this row with each of the columns of the transpose of D, we will get this. So for instance, when we multiply this row and this column, it will be 6 minus 4 minus 2, and that's 0. And then if we multiply it with this, well, we will get these zeros. Okay, so if we set the first column of A to the last row of this V, then we will get these zeros, as we just saw. Okay, so the question now remains, what should we have here? We should have numbers so that the product of D and A becomes positive. I mean, these numbers should be positive. Okay, so what we can do is to we have this this is D and this is the A that we know so far, the first column, and we can select the second column as we wish, so that it fulfills what we want, but we can decide which values of this that we want. Okay, and the criterion is that they should all be greater than or equal to 1. Okay, but we can solve this easily and select such, for instance, the smallest number that satisfies this, and then we will get this. Okay, so now we have computed the A, and this is not, A is not the unimodular matrix, so we are not finished yet. But what we will do is to compute a unimodular matrix, the transformation matrix, from this A. And that's what we will look at next.